Hello everyone. In this session, let me continue few more problems which we are doing in a previous session. So next problem, it is important. Evaluate sin pi into z square plus cos pi into z square divided by z minus 2 into z minus 1 whole square into dz, where curve equation is given by mod z is equal to 3. Anyhow, curve is a circle, so mod z is equal to 3. Now, before solving the problem, you can look at the numerator. Numerator is expressed as sum of two terms. Fine. So, in order to make simplification easy, let me split the numerator. So, given integral can be written as I can be written as, I am going to write this as sin pi z square. It is not sin square pi z, it is sin by z square. Remember, divided by z minus 2 into z minus 1 whole square into dz plus integral over c cos pi z square divided by z minus 2 into z minus 1 whole square dz. Fine. Why? Because when you're going to add these two, you will get back the given problem only. So I can rewrite the given problem as sum of the two integral. Fine. So let me take this as equation 1. Now, in equation 1, we have two integral, whereas denominator is, it is like a product of two function. Again, we have to split this by using partial fraction. So use partial fraction for a denominator. So let me consider, anyhow denominator in both the integral is same. So let me consider a denominator. It is 1 divided by z minus 2 into z minus 1 whole square. It can be written as a divided by z minus 2 plus b divided by z minus 1 plus c divided by z minus 1 whole square. Anyhow, you are familiar with partial fraction, so I am doing the same. Now I can write this as 1 is equal to a into z minus 2 goes up, so left with z minus 1 whole square plus b into z minus 1 term goes, so you will get z minus 2 into z minus 1 plus c into z minus 2. Now, since we have 1 and 2 here, so let me equate the coefficients of, before equating the coefficient, so I can put the values for z, right? So let me put z is equal to 1, so that a and b goes up, you will get the value of c. So 1 is equal to c into 1 minus 2. That will give us c into minus 1. So the value of c is minus 1. Similarly, let me put z is equal to 2. So when you would put z is equal to 2, b and c will not be there. So 1 is equal to a into 2 minus 1 whole square. So 1 is equal to 2 minus 1 is 1. So the value of a is 1. Now we don't have any value to substitute in c to obtain the value of b, right? So let me equate the coefficient. So let me equate coefficients of constants. Why? Because we don't have any square term. So if you are going to equate z, we don't have any z term containing z in LHS part. So let me equate, since in the LHS we have only constant term, so let me equate coefficient of constant. So in LHS what we have, constant is 1. So in this term definitely there is a constant. So I'll simplify here. So a into z minus 1 whole square is a square plus b square minus 2ab. Here constant is a into 1 is a. So constant term is a. Fine. Similarly, simplify this term. So you will get b into z is z square minus z into 1 is z minus 2z minus into minus plus 2 into 1 is 2. So in this term constant is b into 2, that is plus 2b. Clear? Similarly, in this term constant is minus 2c. Fine. I have equated coefficient of constant. Why? Because in the LHS I have only constant. So I can substitute the value of a and c here. So a is equal to 1 plus 2 into b minus 2 into c is 1. So 1 minus 2 is minus 1. So let me shift here. So, or else let me simplify one more step. So a value is 1, b value is, c value is minus 1, right? So you will get 1 minus of minus is plus 2 plus 2b is equal to 1. 1 get cancelled, so you will get, I'll write here 2 plus 2b is equal to 0. What is the common term? 2. So 1 plus b is equal to 0, or else b is equal to minus 1. So I have obtained the values of a, b and c. Now the required fraction I am going to write here, z minus 2 into z minus 1 whole square can be written as 1 divided by z minus 2. b is minus 1. So minus 1 divided by z minus 1. c is minus 1. So minus 1 divided by z minus 1 whole square by using partial fraction. Now let me consider the first term, first integral of a given one. Let me take this as I1, this as I2. Clear? Now I1 can be written as See here, how can we write I1 as sine pi z square divided by z minus 2 into z minus 1 whole square is equal to sine pi z square. I am going to keep as it is, divided by, I am going to write denominator as, I am going to apply this partial fraction. So I can write this as integral over z minus 2 dz minus sine pi z square divided by z minus 1 into dz minus sine pi z square divided by z minus 1 whole square into dz. Fine. What I have done is I have splitted the denominator of a first integral, so I can write like this. Fine. Now you can note that the value of a, compare it with the Cauchy's integral theorem. Integral formula. Here the value of a is 2 and here the value of a is 1. In this case the value of a is 1. Given circle is of radius 3. Clearly 1 and 2 lies inside 3, right? So circle equation is something like this. So radius is 3, meaning is here to here distance is 3. So when I said 2 and 1, it will be lies inside the circle. So as I said earlier, when the point lies inside the circle, we have to apply Cauchy's integral formula. So what is the formula says? Let me write here. So f of z divided by z minus a into dz can be written as f of a into 2 pi I, right? So this is by Cauchy's integral formula. So I am going to apply this concept here. Comparing with the standard forms of the first integral, you can note that f of z value is sine pi z square. F of z value is sine pi z square by comparing it with the standard form. So this integral will become f of a value is 2, f of 2 into 2 pi I. Similarly, this will become f of a value is 1, so f of 1 into 2 pi I minus this value is a value is 1, but here I cannot apply Cauchy's integral formula. But why? Because we have a power here, but we can apply generalized form. So what is the generalized form says? So if you want, I'll write here. So generalized form is f of z divided by z minus a power of n plus 1 will be equal to, into dz will be equal to f power of n of a into 2 pi I divided by n factorial. So this is what the generalized form of Cauchy's integral theorem is. So when you have powers other than 1, so here I have 2. 2 can be expressed as 1 plus 1, right? So 2 can be written as 1 plus 1. Let me write here. So I can write this as f of z divided by, f of z is sine pi z square, right? So let me write directly sine pi z square divided by, I can write this as z minus 1 whole power of 1 plus 1. So in place of n I have to put 1. So you will get this value as f dash of a is 1. So f dash of 1 is 1 into 2 pi I divided by n value is 1. Comparing with the standard form, I am going to write this as 1 factorial. So I can write here directly minus f dash of 1 into 2 pi I. Clear? Anyhow, f of z I have written here. Let me calculate f of 2 value. So f of 2 will be sine of pi, 2 square is 4. So remember, before going to do this, I'll tell you the basic concept and you have to remember this. Anyhow, you have already learnt in your high school, PU. So sine pi z value or sine n pi value will be always equal to 0. Remember, sine n pi, whatever may be the value of n, if you are going to get sine n pi, the value is 0. Similarly, cos n pi is equal to minus 1 power of n. Remember these two values. Now sin n pi, n in the sense 4. So 4 pi value is 0. So f of 2 value is 0. I can write this as 0 into anything will be 0. Minus f of 1 value I need. When you're going to put it here in place of z1, f of 1 will be, let me write here. So f of 1 will be sin of 1 into 1 square is 1. 1 into pi, sin pi is 0. Again this term will not be there. So 0. Minus 2 pi I into f dash of 1 I have f of z as, let me write f dash here. I am going to simplify here. See here, f of z is equal to sin of pi z square. What I need is f dash of z. Let me differentiate. Differentiation of sin theta is minus cos pi z square. Again you have to differentiate inside term. So z square differentiation is 2z. Anyhow pi is constant, I can retain as it is. Now what I need is f dash 1 value. So let me replace z with 1. Minus cos pi into pi into 2 z value is 1. Now just now I have told you that cos n pi value is minus 1 power of n. So remember cos n pi is minus 1 power of n. So here n value is 1. So minus 1 power of 1 will be 1. So cos pi value is minus 1. So I can write this as minus of minus 1 into 2 pi. So minus of minus will become plus. You will get pi 2 or 2 pi. So f dash of 1 value is 2 pi. So I can replace f dash as 2 pi. 2 pi into 2 pi I. That is what I have written. Hope so it is clear for you. So all these steps are not clearly explained in the notes. So I am explaining all this for your reference. Now what I have obtained is, so f dash of 1 value is minus of cos pi is minus 1. Oh, I'm sorry, I have done a mistake here. Differentiation of sin theta is plus cos theta. I'm sorry. So you will get minus here. So you will get minus 2 pi. So minus 2 pi. Minus 2 pi I into minus 2 pi will be, minus into minus is plus 4 pi I. So first integral I1 value what we obtained is 4 pi I. Clear? Now what I have done is I have splitted the given problem into two integrals. So first integral value I have obtained. Similarly I have to evaluate the second integral. So let me evaluate second integral. Let me write the second integral. I2 value is second integral I am going to write. It is what we have, cos of pi z square, cos of pi into z square divided by z minus 2 into z minus 1 whole square into dz. Anyhow I have splitted the denominator, so I can apply directly as we done for the first integral. So what can I write is cos of pi into z square divided by z minus 2 into dz minus cos of pi into z square divided by z minus 1 into dz minus cos of pi into z square divided by z minus 1 whole square into dz. So I have used this partial fractions to split the denominator and I have applied it directly. Clear? Now let me apply the Cauchy's integral formula that I have already applied for the first case. So same procedure you have to follow. Whatever I have done it for the first integral, you have to do for this. You have to do the same for second integral. So let me do here. Now compare with the standard form. Here f of z value is cos of pi into z square. Clear? Now let me find f dash. Why? Because in the third integral you need, right? Anyhow let me keep as it is. First step I am going to apply here. So f of z value is cos pi z square. Here z value, a value is 2. Anyhow all the point 2 and 1 lies inside the circle. So I can write this as, by applying the theorem, f of 2 into 2 pi I minus, for this one f of 1 into 2 pi I minus this one I have to apply Cauchy's generalized formula. That's just now I have done for the first case, no? So I have to apply this formula. So when I'm going to apply this formula here for this term, how can I write this as f dash of a is 1 into 2 pi I. Clear? See here I have done here for the first case. Similarly I have applied it for the second case. Fine, it is for generalized formula. Why? Because power is 2. Other than 1 when you have to apply generalized formula. Clear? Now f of 2 value let me calculate. F of 2 is equal to cos of pi into 2 square is 4. So just now I have told you cos n pi value is minus 1 power of n. Here n value is 4. So minus 1 power of 4 is 1. So cos pi 4 pi is 1. Fine. So f of 2 value is 1. 1 into 2 pi I minus f of 1 value. Replace z with 1. So you will get cos of pi into 1 square is 1. Cos pi value. So n is equal to 1 here. Minus 1 power of 1 is minus 1 you will get. So minus 1 into 2 pi I. Now I need the value of f dash of z. So let me find f dash of z. I have f of z. F dash of z will be, differentiation of cos theta is minus sin theta. Again I have to differentiate this. You will get 2 pi z. Fine. Now let me evaluate f dash of 1. Minus sin into pi value is 1 into 2 pi into 1. Anyhow sin pi value is 0. So this term will not be there. So f dash of 1 value is 0. So I can write minus 0 into 2 pi I. Anyhow this term will not be there. 0 into anything will be 0. Now what I am going to get? 2 pi I minus of minus plus 2 pi I. 1 into 2 pi is 2 pi. So you will get 4 pi I. So the value of integral I2 is 4 pi I, whereas I1 is 4 pi I. So now I have already taken 1, right? So let me take it as 2 and this as 3. Now look at the equation 1 for a given problem, I have splitted the given problem into two. So first I have to add the first integral value, that is I1, and the second integral value I2. So I have obtained the value of I1 as 4 pi I and I2 as 4 pi I. Now I have to add both the values in order to get the solution. Fine. So let me do that. I1 is 2 pi I into minus 2 pi is 4 pi square I, whereas I2 is 4 pi I. So solution of a given integral I am going to write here. Just let me write here only. So in equation 1 I am going to substitute. So equation 1 implies, equation 1 what we have, this integral I1 value plus I2 value. I1 value is 4 pi square I. So in RHS what we have, sine of pi z square plus cos of pi z square divided by z minus 2 into z minus 1 whole square is equal to I1 value is 4 pi square I plus I2 value is 4 pi I. Now what is the common between these two terms? 4 pi I. So when you take 4 pi I common, you will get pi plus, here I have already taken, so it is pi 4 pi I into pi plus 1. I am just repeating once again, since in the numerator you have sum of two terms, so you can split the numerator as I done here. Now we have to split the denominator by applying the partial fraction. So I have obtained the values of A, B, C. Now let me take I1 integral and apply the partial fraction obtained term. I have done this, and for the first two terms in the denominator power is 1, so I can directly apply Cauchy's integral formula given by this. Whereas comparing that, f of z is numerator value, so I have written here, to find the f of 2 value I have to replace z with 2. To find f of 1 value I have to replace z with 1. Anyhow given circle is z is equal to 3, so here the points are 2 and 1, so both 2 and 1 lies inside the circle. That is why I am applying Cauchy's integral formula. Otherwise you would have applied what we say Cauchy's integral theorem, thereby value goes to 0. So if you understand previous problems, then only you will understand this. Now in the denominator of the third term we have a power 2, so when you have power other than 1 we have to apply generalized formula. That is what I have written here, generalized formula. So I have solved the same and I have applied, in place of n I have 1 here, so I have applied here. See, I have simplified this term here. Here it is. Fine. So sin pi z square z minus 1, 2 can be written as 1 plus 1. So in place of n I have 1. So I can write this as f dash of 1 divided by 2 pi I into n. Now f dash I needed, so I have differentiated sin pi z square. So I have done here, f of z is sin pi z square. F dash is cos of pi z square into, again I have to differentiate this. Remember I have to differentiate this again by using chain rule. So f dash of 1 I have obtained. I have replaced here I1 value, I done. Now I'm sorry, I did. Now second integral value I have to obtain. So let me take a second integral value and apply the partial fraction. Followed the same method that I have done in the first case and substitute I1 and I2 integral value in I. So that is why the solution, and that is what the solution is. Now you can note that in the denominator I have z minus 1 whole square and z minus 2 terms. Now I'll give you the homework problem of same kind. So let me know the solution. Here is the homework problem, where you can note that I have not given square here. Fine. So use the same method and solve and let me know the solution. Please post it in a group. And here is the answer. It is, you have to obtain answer 4 pi. Please don't set it. You have to simplify as I done in this problem so that you will get the solution 4 pi I. Hope so it is clear, and both the problems are important for you. So you solve this. If you are not getting, I will send you the solution. Please go through that. Fine. Hope so it is clear. Now let me solve one more problem. Here is a problem. So z minus 3 divided by z square plus 2z plus 5 into dz, where curve equation is a circle. It is given by mod z is equal to 1. Fine. Now let me evaluate. So you can note that denominator is quadratic equation, that is z square plus 2z plus 5. So we have to simplify this. Anyhow there is no direct factors for this, so let me evaluate by using the formula method. Minus b plus or minus b square minus 4ac divided by 2a. So a value is 1, b value is 2, c value is 5. So let me substitute. Z is equal to minus 2 plus or minus square root of 2 square minus 4ac is 5 divided by 2 into a. Let me simplify here. So you will get minus 2 plus or minus square root of 2 square is 4 minus 4 5 is 20 divided by 2. So you will get z is equal to minus 2 plus or minus 4 minus 20 is minus 16. So I can write that as I into root 16, right? So you are already familiar with this. minus 16 can be written as I into root 16. I can be taken outside. Why? Because I value is minus root 1. So I can write this. Now the square root of 16 is 4 divided by 2. So take 2 common in the numerator. So you will get z is equal to minus 1 plus or minus I into 2. Clear? In the denominator I have obtained complex number. Now since it is a quadratic equation, it has two roots, right? So one value of z is minus 1 plus 2i and another value of z is minus 1 minus 2i. Fine. Let me take this value as alpha and this value as beta. That is alpha is equal to minus 1 plus 2i, beta is minus 1 minus 2i. Clear? Now given equation of circle is mod z is equal to 1. In the sense radius is 1 unit. So here is a 1 unit. Distance from here to here is 1 unit. Clear? And you already know that finding the radius of a complex number, right? So x plus iy, when you have a number like this, radius can be obtained by using the formula x square plus y square. You are already familiar with this in your PU class, right? So by that I can write the radius as for alpha. It is 1 square minus 1 square is 1 plus 2 square is 4. So 1 plus 4 is square root of 5. It is something like 2.5, right? Whatever may be the 2 point some value you will get. Fine. Again for beta, I will apply the same procedure. Minus 1 square is 1 plus minus 2 square is 4. Again it is 2 point something, right? Anyhow radius is 1. You are getting the values of alpha and beta as 2 point something. So anyhow it lies outside the circle. Remember, as I already told you a number of times, when a point lies outside the circle, you can apply by Cauchy's integral theorem. When point lies outside the circle, you have to apply Cauchy's integral theorem. When point lies inside the circle, you have to apply Cauchy's integral formula. Now given problem can be written as what you come to know that alpha and beta both are outside the given circle. So I can write here alpha and beta lies outside the given circle. Outside the given circle. Fine. So given problem can be written as z minus 3 divided by z square plus 2z plus 5 can be written as z minus 3 divided by z minus alpha into z minus beta, right? So if you substitute alpha and beta here and if you multiply, you will get back this. That is what the meaning of factorization is. Fine. So here, since alpha and beta lies outside the circle, therefore I can apply Cauchy's integral theorem. Therefore by Cauchy's integral theorem, what is the value? What is the Cauchy's integral theorem says? F of z divided by z minus a into dz value is 0. So as per that theorem, Cauchy's integral theorem, what I can say, that given integral value is 0. Fine. You have to know that if the point lies inside, you have to apply formula. Cauchy's integral formula, it is given by f of z divided by z minus a into dz is equal to 2 pi I into f of a. You have to remember this formula. When point lies inside. When point lies outside, you have to remember this formula. This is called as Cauchy's integral theorem. So by Cauchy's integral theorem, the value for given integral goes to 0. Hope so it is clear for you. Let me solve one more problem. So here is the problem. Evaluate integral over line integral over c e power of z divided by z minus 1 power of 3 into z dz, where circle equation is mod z is equal to 2. Circular curve equation is mod z is equal to 2. Remember, it is a curve equation. Maybe they will give ellipse and hyperbola sometimes. Right now we have a circle. That's all. Now before solving the solution, you have to make sure that power of z minus a term should be 1 when we have to apply Cauchy's integral formula. But here it is not the case, where we have a power 3. Remember, when we have power other than 1, you have to apply generalized Cauchy's integral formula. And the Cauchy's integral formula is given by f power of n of a. I have solved this derivation. If you want, you can go through that. So n factorial divided by 2 pi I into f of z divided by z minus a power of n plus 1 into dz. Anyhow, I have applied this in a previous problem, but before that I have to solve this. Anyhow, let it be. So I need a expression which is of this form, right? So f of z divided by z minus a power of n plus 1. So I'll keep this one side. So I'll shift remaining so that I'll get f of z divided by z minus a power of n plus 1 into dz will be equal to, cross multiply, you will get 2 pi I into f power of n into a into n factorial. You will get, n factorial will comes to denominator, right? Divided by n factorial, I can write here. Fine. Now compare with the standard form, you have f of z value as e power of z and a value is 1, right? So the solution for the given problem will be 2 pi I into f power of n of a. So in place of n what I have, so let me write one more step, f of z divided by z minus 1 power of n plus 1 term I have to write in the form of n plus 1, I have to x plus 3. So 3 can be written as 2 plus 1, right? Now you compare, so n value will be equal to 2. So what can I write this as? 2 pi I into f power of n is 2, that is I can write double dash here of a is 1, f double dash of 1 divided by n value is 2, so it is 2 factorial. I can write this as 2 pi I into 2 factorial is 2, f double dash I need, so f of z is, I'll simplify here, f of z is e power of z, so f dash of z is e power of z is e power of z only, f double dash of z is also e power of z only. So what I need is f double dash of 1, so let me replace e with z with 1, so you will get f double dash of 1 as e. So let me substitute here, it is e, 2 get cancelled, so what is the solution I have? E into pi a. So required integral value e power of z into z minus 1 cube is equal to e into pi a. So only thing is, when you have power more than 1 of z minus a term, you have to apply generalized form of Cauchy's integral formula. Hope so it is clear. So in the next session, let me solve few more problem based on the given concept. Before that, please let me know the solution of a homework problem. Anyhow, I have already given the solution also. Please solve the same and put it in a group. Thank you. Continue in the next.